Okay, so yeah, what were we doing? We had this option where you could, if it was not dependent on three stocks, if stock three was below $30, you had the right to buy a share in stock one for $10 at the same time sell a share in stock two for $20. So it was like a put and a call kind of put together with this stock three switch on it. We used that multidimensional, the solution to the multidimensional Black-Scholes equation, and we got down to all we have to do is solve this integral, which admittedly is a big, looks like it's going to be hard to actually do pencil and paper. So we decided to do this using Monte Carlo integration, because that'll be quick and dirty, the easiest way we can think about it. So now that's what we're talking about in this video. We want to solve this integral using Monte Carlo integration. So Monte Carlo integration, I want to get the volume of this shape. So now we had our shape here that was in the purple. So on the purple side of that plane and below the purple side of the stock 3 has to be less than $30 plane. So we want to integrate over that shape. So we need the volume of that shape and then multiply it by the expected value. That should give us the value for this integral. Now this infinity in here, well, okay, I'm going to make some assumptions then. We had made some assumptions about stock 1 and stock 2, and I think the assumptions that we put in, or the values for stock 1 was $11. So even though technically it's allowed to go to infinity, stock 1, I'm going to make the assumption that I'm going to cap this infinity at 90. So I can use Monte Carlo integration. So then the volume, let's get the volume of this shape. The volume is going to be 30, the height, times the area of this, well, let's make it a trapezoid. I only want to go up to, in stock 1, I only want to go up to $90. And you can see why I picked, you'll see why I picked 90 instead of 100, which seems like a good round number. But this is like that the line raised up $10. So that's going to be the area of this trapezoid. So small height plus long height average times this 90, and then that's the area of the trapezoid times the 30 will give us this shape in here. So this, there's the volume. So I've already got this value. I just need to know the expected value of this integral. This 22 point, this was the front matter for all of that that integral. That was the e to the minus r t minus t and divided by the square root of the 2 pi. That was all the constant stuff. So let's just worry about this integral. So I need the expected value. And when I say expected value of what? Of the function I'm integrating. I'm talking about the expected value of this. So let's get that. We're going to loop over 1,000 times. I'm going to uniformly pick a point in the box. In what box? I'm talking about in this purple region, in this trapezoidal box. It's going to be more difficult to pick uniformly. Why? Because uniform random numbers over an interval, that's super straightforward, but I don't want my numbers to bunch up. So I'm going to pick a kind of a crude way. I'm going to pick uniformly in this whole box. So I'm going to pick 3 uniform random numbers. One for x. So u sub 1 times 90, we'll pick a uniform x coordinate. u2 times 100, we'll pick a uniform y coordinate. And u3 times 30, we'll pick a uniform z coordinate that's for sure inside the feasible region, below this purple, below that purple plane. So when I do that, I'm in that box, but I want to be on this side, on the purple side of the plane. So if I happen to be outside on the red side of that plane, then I'm just going to pick again. So I'm not going to do anything clever. I'm just going to pick a point uniformly over the box, because I know I know I can do that. If it's outside the feasible region, in other words, if it's not in here on the purple side of everything, then I'm just going to pick the point again. That's what I'm saying here. So if y2 is bigger than that plane, y1 minus or y1 plus 10, pick another point. Once I get a point that's in the feasible region, the purple and purple side, I'm just going to evaluate. I'm going to evaluate this piece that I'm integrating, and I'm going to add that to the total. Then I'm going to do this 1,000 times. So then the expected value will just be the average, that total divided by 1,000 divided by n. Once I get that value, I'm going to multiply it by the volume. This 22.552 is just that stuff that's outside. And when I finish that, it should give me the value of that option right now. So the only thing left to do is build the MATLAB code that's just going to whip through this loop 1,000 times. So, and I guess I could do that in Excel as well, right? With some if-then statements, we could do that in Excel. Typing this formula though in Excel is going to be, well, typing it in MATLAB is not going to be great either. But let's open up let's do it in MATLAB. So we got to go to MATLAB here to run this loop over and over and over again, 1,000 times, let's say. So let's take a look at our MATLAB code, my MATLAB code. The total, I'm blanking it out to 0. I'm going to run it 1,000 times. So I'm picking 1,000 points in the feasible region. So we're talking about I need to be picking on the purple side of everything. So I'm first picking a point in that box, X, Y, Z, or Y1, Y2, Y3 point in the box. And I got to check if I'm on the purple side of this plane here. In other words, do I want to evaluate it? So here's my while loop. So if I'm on the right side, then this is true, and I can just jump right down to evaluate and add to the total. If it's not, I'm picking the Y1 and Y2 again. I don't need to pick the Y3 because the Y3 is already in the box. The box is just Y3, the Z value is 0 to 30. Once I get a good point, a point that's on the purple side of everything, then I'm plugging it into this expression, which is huge, and there's a lot of places to make errors. So I separated it out. First I'm evaluating this top part. So that's what's here. Evaluating the top, and then the total is equal to the total plus. I add on each time our e to the minus top divided by 2, and there's that payoff, and divided by all the product of the y's. And then in the end, I want the expected value, so I need to take that total divided by n, the number of times I run it. So let's run it, and I get an answer of 2.53 or 2.5-ish, 10 to the minus 7. If I run it a couple of times, I'm getting, yeah, okay, around that magnitude. But it seems to be jumping around a bit, and since I got the MATLAB code open, let's do it 10,000 times and just see. Now I'm getting consistently something 10 to the minus 7, feel a little bit more confident. My confidence interval will be smaller. Let's do 100,000 just to see. And now it's always to the minus 7. I can say it's about 4 point. again, there's random numbers. Let's, okay, push there. 4.5 times 10 to the minus 7 is what I'm getting. And I need to multiply this answer. That's this expected value. I need to multiply it by the 22.552. That's the stuff outside the integral, and the volume of that box that we're in, the volume of that trapezoidal box. So I could multiply it here by the value that I got. Well, let's do that. I'm getting this, so I ran it, times 10 to the minus 7. So this, I want that to be a number. Times 10 to the minus 7. And this will be my estimate then for the price of this option. $1.52. We use Monte Carlo integration to do the integral that we set up as a solution to that multi-dimensional Black-Scholes equation. And $1.52 doesn't seem unreasonable.